Hello, everybody, and welcome to Homework Helper 8.6. Let's do this thing. All right. First thing is identifying the features of functions, and then it tells us exactly what features it wants us to know. It wants us to come up with the domain, the range, and then indicate whether each function is discrete. Remember, that's like buckets in a water, where it goes like that. Continuous, where it would be a straight line up, or discontinuous. So what does discontinuous mean? Well, it's kind of a mix where yeah, it does continue, but maybe we have like a jump around. So while it continues to pass the vertical line test, maybe it jumps, but a continuous line that is jumping, you know. So, and whether it's increasing, decreasing, or constant, which means it would be flat. So let's go ahead and look at this first one, okay? So we have this from here. So what is the domain, what is the range? The domain goes from -5 to 5, -5 to 5, or if you want to write it the way we've been doing it recently, we would write it like this. The range goes from 0 to, is that 10? 10? So from 0 to 10, or 0 is less than or equal to y is less than or equal to 10. And, okay, cool. We got our domain or range. Is it discrete, continuous, or discontinuous? It's one solid straight line, so this is continuous. Is it increasing, decreasing, or constant? As we go left to right, it's going up, so it's increasing. One of the ways I kind of think about it is like if I was playing like Super Mario Brothers or a side-scrolling video game, is if this were on the screen, would my character be moving up or down, and my character would be moving up. Okay. All right, let's look at this next one. All right, domain. So let's look at our x's. Yes, 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 yes. Oh, and look here, even though this is a dark dot, this is an open dot. So it kind of like jumps. There's never a point where the domain is not happening, because even though it goes from this line, it then continues onto this line, and likewise here. So all of our domain from -10 to 10 is covered. So domain from -10 to 10, or if I was going to write it the other way, -10 is less than or equal to x is less than or equal to 10. And then let's look at our range, -4, and then it doesn't stop till 9. So -4 to 9, but then look at 9 here. 9, it's an open circle. Or is that 9? I'm sorry, that's 7. That's 7. 7. And then it goes all the way up to 7. But it's an open circle, so it doesn't actually touch 7. So I'm going to use the parentheses to say that it comes as close to 7 as possible without being 7. Because the parentheses and the open circle communicate the same thing. -4 is less than or equal to y, which is less than 7. Same deal here. I use the less than symbol. So what I really want you guys to notice is that open circle, parentheses, and the less than without the or equals to sign are all communicating the same thing. That's that connections piece when we talk about our math habits of mind. Okay, so that's pretty much what you'll be doing for these. Let me give a peek to see if any of these are extra hard. No, you should be able to do most of these. Cool. So let's go to the next section. All right, square root functions. So we kind of tease square root functions in some of our classroom activities. So here's a chance to actually see them in the wild. So let's go ahead and read this first one. The speed limit for driving in a school zone is 20 miles per hour. That seems so slow if you're riding in a car. But have you ever wondered how quickly you could come to a complete stop going that speed, even if you had super quick reflexes? It would take you over 13 feet. The speed of a vehicle and the stopping distance d are related by the function the speed of d equals the square root of 30 times d. Okay, so this is a real-world mathematical application problem. So let's go ahead and fill in the table of values and see what happens. So for this one, you know, we're gonna have 25 as our d, so we need to plug it into our equation here. So let's go ahead and do that. So we're gonna have the square root of 30 times d, which is gonna be 25. And when we do that, that's 5 root 30, but I wanna know exactly how much that is, because I'm gonna have to graph this. So let me go to mode, let me go to classic. Okay, so now I'll go back, clear. So let's try it again. So square root 30 times, 30, wait, no. What am I doing? Delete, delete, delete. 30 times, there we go. 30 times 25, close those parentheses. 27.38. It says round to the nearest whole number. The nearest whole number is going to be 27. Okay, so if I wanted to stop in 25 feet, then I have to be going 27 miles per hour. Okay, let's try the next one, 50. So square root 50 times 30, 39. So if I wanted to stop in 50 feet, I have to be going no more than 39 miles per hour. Square root of 100 times 30, 45, or I'm sorry, 54. I'm sorry, 55, it's gonna actually round up, huh? 55. So if I wanna stop at 100 feet, I have to be going no more than 55 miles per hour. 77. 77 miles per hour means I can stop in 200 feet. And last one, 95. And so if I want to stop in 300 feet, I can't be going faster than 95 miles per hour. Okay, so now let's graph it. So here's our stopping distance. At 25, we need to be going 27. So 5, 10, 15, 20, 25, 7. 50 is 39. So 5, 10, 15, 20, 25, 30, 35, 40. So a little under 40. At 100, it's 55. 100 is 55. 200 is 77. So that's 50, 55, 60, 65, 70, 75, 77. 300 is 95. So that's going to be 300, 100 to 95. Cool. So this is what it looks like. That's our square root function. Okay. And so you'll just continue to build from this original data for the next few questions. We'll be able to figure this out. And it looks like the next one, we're going to take the inverse, right? It looks like this one, where this was speed on our y, speed is now on our x. Where this was stopping distance on our x, it's now on our y. So we're going to invert it, right? We're going to flip it. That doesn't work as well, but we're going to end up mirroring it on itself and see how that behaves. So you'll switch your x and your y values to see what it looks like. All right. Next section is literal equations. So when we're solving literal equations, we're trying to solve for just one variable. This is the classic, the circumference equals 2 times pi times the radius. It wants us to get our radius by itself. So to get the radius by itself, we divide by 2 pi. So c over 2 pi equals r, and we've done it. But the rest of these are a little bit more complicated because they have squares. So for example, this is the area of a circle. Area equals pi r squared. And we want to get r by itself, so we need to divide by pi. So we have a over pi equals r squared, and then we need to square root it. So that r equals the square root of area over pi. Now, is it plus or minus square root here? It's only going to be plus, because when we're talking about measurements of space, it's only going to be a positive number. But we can imagine situations where this might be 2 answers. But since we're talking about area, it doesn't make sense to have a negative area or a negative radius. So we're only going to look at the positive values here. Okay, and so that's what we're going to be doing for all of these. Let's look at maybe 14. I'll do this one here. It wants to solve for r again. Okay, so this is the volume of a cylinder, right? We took pi r squared, which we already have, but then we multiply by height, so that becomes like a can. It becomes like a cylinder. So let's go ahead and do that. I want to get r by itself first, so I need to divide by pi h, volume over pi times height equals radius squared, and then I just square root both sides. R equals the square root of the volume divided by the pi, divided by pi and the height. Cool. And like you can imagine, like I could do that with my water bottle. Like I can measure, I can take a ruler, figure out how high my water bottle is. I could then, if it said on it, I don't think mine actually says on it, but oh yeah, right, no it doesn't. Some water bottles will say what its volume is, like this is 16 ounces or 20 ounces, right? And so I could say, okay, I could figure out what the radius is I could figure out what the center, I could figure out what that measurement was without measuring it. If I knew the volume, like let's say it was 20 ounces divided by pi times the height, and I measure it and it's 8 inches. And then I take the square root of that number and I could figure out what that length is. So if this were true for my water bottle, for example, I could do 20 divided by, let's say, where's pi? Whoops, pi times 8. And then I just need to take the square root of that number. Boom, 0.89. So this is like 0.89 inches or what have you. Cool. Or the radius is 0.89 inches. From here to here is a little less than an inch. And that's probably true. True-ish. I mean, I did make up some of those numbers. But anyway, there you go. That's how we do it. Have fun, and I will see you next time.